こんにちは。テスラ全力チャンネルの太一です。昨日のインベスターデーのまとめ動画では多くのご質問をいただきました。その中で最も多くいただいたのが、結局マスタープランは何だったのということです。確かにマスタープラン3以外の部分でフォーカスされがちでしたが、マスタープラン3にはなぜメディアが大々的に触れないのかと思うほど重要なポイントがありました。ただ長すぎてというか壮大すぎてピンとこなかった可能性もあります。今回はこうしたご質問に答えるべく4時間のキーノートを10分にギュッと凝縮してマスタープラン3の中の5つの項目を個別に詳しく解説しようと思います。まずはイーロンマスクの解説で要点だけを編集したサマリー映像をご覧ください。
All right, Master Plan Part 3. The story, and I think that this holds together quite well, and we'll be actually publishing a detailed white paper with all of our assumptions and calculations, is that there is a clear path to a fully sustainable Earth with abundance. In fact, you could support a civilization much bigger than Earth, than much more than the 8 billion humans. And I'm just often shocked and surprised by how few people realize this. So we're going to walk through the calculations for how to create a sustainable energy civilization.
And to set the stage, today our energy economy, let's be honest, it's dirty and it's wasteful. Over 80% of global energy, primary energy, comes from fossil fuels, and only 1/3 of that global energy actually ends up delivering useful work or heat. This is the problem statement, but we're here to talk about the solution.
So if you have a gasoline car, you're converting less than a third, often maybe only 25% of the energy in the gasoline is converted into motion. The rest is turned into waste heat. That doesn't do any good at all. And there's a lot of energy required even to get the oil out of the ground, to refine the oil, and to transport the gasoline to the gas station. So when you look at all that, for a typical gasoline car is actually going to be using less than 20% fully considered of the energy from the oil actually goes into motion. So this is when we see people doing calculations for what does it take to create a sustainable energy Earth, they assume that the same energy amount is required for an electrified civilization versus a combustion civilization. This is not true, because most of the energy of combustion is waste heat.
But the nice thing about an electrified economy, through end-use efficiency and through efficiency along every step of the way, actually the total energy use halves. So this is one of the most enabling aspects of electrifying everything, is that the sustainable energy economy is that much easier to accomplish. It's actually half the problem statement of the fossil fuel economy. So how the master plan works, you want to talk about?
The thing that is needed at very large scale that is not currently present is a vast amount of battery energy storage. Our rough calculations are that this is about 240 terawatt hours, or 240,000 gigawatt hours. So if you've got solar or wind, you've got to store the energy when the wind is not blowing, the sun is not shining. Our capital expenditure calculation for manufacturing investment is more like 6 trillion, but we made it higher to make it 10 trillion.
And this is across mining, refining, battery factories, recycling, vehicle factories, all the things that we're going to talk about needing to invest in to build this sustainable energy economy.
Yeah. Now, if you look at the total world economy, it's just under 100 trillion. So if this was spread out, say, over 10 years, it would be 1% of the global economy. Over 20 years, it would be 0.5% of the global economy. So this is, not a big number relative to the global economy. As Drew mentioned, you need about half as much energy with an electric economy versus a combustion economy. And in terms of wind and solar, how much land would be used? It's less than 0.2% of the land area of Earth. The electrified economy will require less mining than the current economy does.
Yes.
Less, not more. Okay.
So this is the plan, and now we'll get into a little bit more of the details of the plan. Basically, 5 areas of work. First, renewable power, the existing grid. Second, switch to electric vehicles. Third, switch homes, businesses, and industry heating to heat pumps. Fourth, high-temp heat delivery and storage for high-temp industrial and chemical processes, and a little bit of green hydrogen in there for chemical processes that need hydrogen. And finally, sustainably fuel planes and boats. These are the 5 areas, and we're going to go into detail on all of them.
Yeah, I mean, my personal opinion is that as we improve the energy density of batteries, you'll see all transportation go fully electric, with the exception of rockets.
So first, repowering the existing grid with renewables. And this is going to be a consistent theme. You'll see our estimates for the number of terawatt hours, terawatts, and trillions of investment at the bottom of the page. You know, this is already actively occurring in front of us. And actually, on a year-on-year basis, solar deployment is growing 50% year-on-year as of 2022. So this is a serious upswing. And if we continue this trend, this is going to be behind us before we even know it.
Yeah.
Second, switching to electric vehicles. Again, 21% reduction in fossil fuel use by doing this alone. Obviously, Tesla is heavily engaged in this activity, along with many others. Overall, EV production grew 59% year-on-year in 2022. And what does this fleet look like? You know, just rough view from our perspective. Of course, we could be wrong, but you know, you can see the sort of breakdown of the fleet by millions of vehicles. You know, our goal is to do 20 million electric vehicles a year. And one of the reasons why EVs are so enabling is this end-use efficiency point. Tesla Model 3, it's 4 times more efficient from the well to wheel than a Toyota Corolla. And that's all about the efficiency of getting the electricity into the car in a sustainable energy economy, and then how efficient the car is in transferring that stored energy to motion on the road. Next, switching to heat pumps in homes, businesses, and industry. You know, right now heat pumps meet 10% of building heating needs. Install rates growing 10% year on year. It really needs to accelerate. Heat pumps can serve, you know, and from an investment perspective, as you can see on this page, this is actually the lowest hanging fruit in terms of displacing fossil fuels. You know, they're all over this factory, they're in your house, and all this really is about bringing them to displace all the fossil fuel heating in all of the homes, business, in the industry that we can. And from an end-use efficiency perspective, there's a three times reduction in the total energy required to heat these buildings. Next, a little bit more detail on electrifying high-temp sort of industrial chemical processes. So over 50% of industrial heat is greater than 400 C. You know, cement, steel, fertilizers, chemicals, plastics, metals refining all need like 1500 C. So we need a solution here. Ultimately, it's purpose-built equipment that enables electrification. You know, carbon graphite is stable up to 2800 C. There's other options in the 1500 C range, like silicon carbide, other materials. And then on the hydrogen side, we also need green hydrogen to decarbonize metals and chemical refining processes. This is things like ammonia, making steel. You know, there's roughly 120 million tons of hydrogen sourced from fossil fuel today to do these things. And hydrogen can also directly replace coal, which is currently used in a ton of steel production. And this is the way to eliminate fossil fuels from these aspects of the economy. And lastly, a small part of the pie, but a necessary part of the pie, is sustainably fueling planes and boats. Shipping accounts for 3% of global CO2. It's ripe for electrification. Even with lithium iron phosphate, long-haul ships can be fully battery-powered. So that's a great opportunity to electrify. Energy density is a little bit harder for planes, but short-haul is doable today. With some improvements, we'll get long-haul underway. But even in the meantime, we can leverage sustainable aviation fuels produced and stored using excess renewable electricity. There's a lot of work going on in this space.
Yeah, I mean, to really get long-range aircraft and long-range shipping to use lithium-ion, you need to redesign the ship and not just...
or the plane.
And the plane. To take advantage of the fact that it is a new source of energy. It's a different architecture. Make it mass efficient and optimized for battery. But I think that price will come down.
So when we stack up all of these efforts, we end up with the numbers we shared at the beginning of the presentation: 30 terawatts, 240 terawatt hours, $10 trillion. And you may be saying, like, I need some context. Is this feasible? Spoiler alert, it's entirely feasible. Just looking at it from a growth rate perspective,
このようにマスタープラン3は既存の電力システムを再生エネルギーに置換すること、EV 社会への完全移行を行うこと、全家庭と工場における暖房機器のヒートポンプ化、産業界でのクリーンエネルギーの貯蔵と輸送、再生可能エネルギーで動く航空機と船舶の開発という5つの項目からなることが分かりました。ついに車だけでなく飛行機にも手を出してしまうのですね。壮大すぎて言葉になりませんが、こうしたプランが実現可能であると言い切っているのです。先ほどの映像の続きは、こうした壮大なマスタープラン3がどのようにして実現されていくのか、なぜそれが実現可能なのかを解説していっているのですが、今回は時間の関係で省略しました。今回のインベスターデーは分かる人には分かる内容だったかと思いますが、明らかに人類の文化圏を地球外に拡張するためのものであることが分かります。特に太陽光や風力を効率的に蓄電し、航空機燃料として活用して、こうした燃料に最適化した航空機そのものを開発するという部分は、非常に壮大なスケールで会場にいた熱心なテスラ信者ですら疑っていたと思います。しかしよく思い出してほしいのは、EV そのものがたった5年前までは絶対に流行らない、そもそも実現すら怪しいと言われていた代物だったということです。このまま化石燃料に頼った生活をしていけば、いつか人類は滅びます。そうなる前にイーロンマスクだけがその解決策を真剣に取り組んで、株主含めて多くの人から白い目を向けられても、信用していた仲間から見捨てられても、資金が底をついても、たった一人で自分の信じる道を邁進し、EV の開発と普及を実現してきたのです。こうしたことを考えると、テスラならやりかねない。そんな期待すら持たせてくれるのがイーロン・マスクです。だからこそテスラへの投資は資産運用的な側面だけではなく、人類の子孫の繁栄という意味で価値と意義の両面において十二分にあるのです。今回の内容は以上です。いつも皆さんからのご意見をコメント欄で読むのが大変楽しみです。応援コメントだけでなくご批判もすべてありがたく読ませてもらっています。この動画へのコメントでなくても簡単な一言でもいただけるとすごく嬉しいです。それでは次回の動画でお会いしましょう。ご視聴ありがとうございました。バイバイ。